right. Hi, guys. Sorry for the two videos. My whole computer system kind of just went down for a second. So this is video number 2, which is the example problems on the second page of our asynchronous notes for today. So we are going to be looking at our first example, which is an example that we're going to look at an example that's being compounded quarterly and an example that's being compounded continuously to show the difference between these two examples. So in example 1, it says an investment of $1,000, that's our principal, earns an annual interest rate of 7.6%. We know that that decimal is 0.076. Our job is to calculate the final amounts after 8 hours, which is our T, for the interest compounded. So if it's asking us to be compounded quarterly, that is where our end value is 4. So we can go ahead and write out the formula. A equals 1,000 times 1 plus 0.076 all over 4 raised to the power of 4 times 8. Now, you could definitely type it in your calculator like this, but we want to make sure that, one, our calculator is reading the order of operations correctly. So we can simplify this a little bit. 1,000 times 1 plus parentheses 0.076 divided by 4 parentheses 4 times 8 is 32. And then we can go ahead. We can write out our investment value after 8 years. Plug this in our calculator, and a ton of stuff in here from earlier. And we can say 1,000 times 1 plus 0.076 divided by 4, parentheses raised to the 32nd power. And that gives us a value of $1,826.31. So $1,826.31. So this is how much money you have after 8 years if it's compounded 4 times per year, right? If it's taken 4 times per year. Now let's take a look and see if the value has any differences when we're looking at something that's being compounded continuously for 8 years, right? So we are going to go ahead and we are going to fill in what we know. We don't know our A value yet. That's what we're looking for. We know the principal is $1,000 times E, which is just an irrational number. So it's kind of like pi. It's just that symbol. It stands for 2.71. It has some decimals after that. E raised to the 0.076, that's our R, times 8, which is our time. So now our rate is also in our exponent, not just the time. So let's go ahead and evaluate this in our calculator. 1,000 times E. Now we can find E by going to our second ln button. If you notice, the E is right there with the exponent raised. We can type in 0.076 times 8, all in that exponent. And we get a value that A is equal to $1,836.75. Now, it makes total sense that this value is more than something that's being compounded quarterly, because if an amount, an interest rate is being compounded quarterly, that's only happening 4 times per year. Whereas this value right here is happening almost like every second, kind of like what we said. It's really not quite there at every second, but it's continuously being compounded. It's like getting really, really, really close and can get super, super big as it gets close to that infinity mark. So that is the example on how they differ. One, compounded interest, continuously compounded interest formula. So for number 2, it says compare the growth of an investment of $2,000 in 2 different accounts. So account 1, account number 2. All right, so it says compare the growth of an investment of $2,000 in 2 different accounts. One account earns 3% annual interest, the other earns 5% annual interest, and both are compounded continuously over 20 years. So if we're taking a look at account number one, we are starting with $2,000, okay, times E raised to the 3% is the decimal of 0.03, and both are compounded continuously over 20 years. So if we do take a look at this value in our calculator, okay, we can say 2,000 times, E raised to the 0.03 times 20 power. So we get that after 20 years, account number one will have $3,644.24. Okay. And if we look at account number two, we know that it still has the same initial value. We're still investing $2,000. But this time it's growing at an annual interest rate of 5%, which is 0.05, but still being evaluated over 20 years. So let's see the difference. 2,000 times E raised to the 0.05 times 20th power, which gives us a value of $5,436.56. So as you can see, account number two, because it earns 5% interest, 5% is 2% more than 3%, right? We know that. So because our annual interest is more, even though they're both being compounded continuously, like constantly all the time for 20 years, because account number two had a 5% annual interest rate, it only makes sense that account number two has more money than account number one. And then example problem number 3, Don plans on buying a used car for $15,000 in 3 years. How much money should he ask his parents for now so that if he invests at 5% compounded continuously, he will have enough money to buy the car in 3 years? So we are actually working backwards here. By asking how much money should he ask for his parents now, okay, that is the initial value, right? So we need to definitely work backwards here. So our amount of the investment that we're ending with is $15,000, okay? We do not know P, but we do know E. E is always there. We know we are going to raise E to a 0.5 decimal, right, for 5%. And we know our time is 3. Okay, so in order for us to kind of work backwards here to find P, we definitely need to focus on this value first. Okay. When we focus on E raised to the 0.05 times 3 power, we get this value of 1.1618. And we can definitely probably round to the nearest hundredth because we're talking about money here. So we know that $15,000 is equal to P times this value right here, 1.16. We can go ahead and divide by 1.16 because the opposite of multiplication is division. Okay? And 15,000 divided by 1.16 gives us 12,931 is our P value. Now, in order for us to check our work, we can go backwards and just make sure that it's correct. So we can pretend that maybe this was our initial value, okay? And we can go ahead and say A is equal to P times E raised to, we know P, sorry guys. We know P is 12,931 times E raised to the 0.05 times 3 power. And we get about $15,000 or $15,023, which is exactly, so it's more than he needs. So that's good, right? Which means that if his parents give him this much money to begin with, then he'll have, not only will he have the $15,000, but he'll have a little bit extra to spend. And I do believe there was a decimal attached with this, so we can definitely change that so it's more accurate. $12,931.03. That is our initial value right there. Okay. And there you have it. We have done a few examples of PERT, something that's continuously compounded. Even though we're not assessing on this right now, it's definitely going to come back in our logs that we're going to talk about starting Thursday. So it is important to have this good understanding of what E is, and we're definitely going to keep diving into it. But for today, this was just a little something to kind of get our feet wet, to feel prepared for what's to come. So by us working backwards, for example, problem number 3, he has more than enough money. So we're all good to go. So with that, I hope you guys have an awesome Asynchronous Wednesday. Today's assignments, not too bad, just 2 videos following along with these example problems, and we will see you in class on Thursday. Bye.